No, when the resources are not there and when the space is high, it will automatically stop, whether it is a new Mac or old Mac. All right. So what we want to do? An ultimate word count, right? So what I'm going to do is mkdir ultimate word count as the name of the, mkdir ultimate word count is the name of the program. cd ultimate word count, cp build.xml to here. That is the basic. Otherwise, if you copy my build.xml, I told you many times it will not work, because your build.xml is referring to your master lib. Clear. Now I need to bring the source. From where I have to bring the source? cp minus r. Again, MapReduce reference concepts 4 no, not concepts 4. Is it in concept 6? No, it is not in concept 6 also. It is there in MapReduce reference slash concepts 3. No, concept 3 Ravi was the vowel partitioner. It should be in concepts 4 slash source slash com slash passion slash no, it is not there in concept 4 also. Where is it? Is there concepts 5 there? Concept 5 is secondary sort. No, concept 7. Let me try. Okay, source com Ravi. No, it is not there. What about concepts 8? Com. No. So to find it out, wait a minute. So what I will do, I will open another command prompt, and in that command prompt, clear cd MapReduce reference. What is the command? Find from here minus iname, and I remember the name of the program is ultimate. So alt star dot java. I want to find out the code called ultimate word. Look at that. That's why I gave you that command. So it is in concept 6. Now you come back and then you are going to copy that, right? MapReduce reference concept 6 and source and com and Ravi, and there is that ultimate word count.java, right? But you are copying to where? Inside ultimate word count. Okay, let us rearrange it later. Ultimate word count.java to here. And I want to copy some more files here. Okay, one is called file 1 dot or file 0 and file 1 dot c. You can see file 01 and file 02. So I want to copy file 0 star dot txt to here. Okay, and then I want to copy patterns.txt also to here. I will tell you why. Okay. And now if I look at ls, I have got file 01, file 02, patterns.txt and ultimate word count.java. But ultimate word count.java is inside the package com.ravi. So I am going to change that one as com.passion. Right? And come out. And then what I need to do, mkdir com and cd com mkdir passion. You can create com slash passion also by some Unix command. I think mkdir minus r or something. So cd passion, and I'm going to move that ultimate word count.java to here. Okay, not cp. Actually, it should be move, because cp will create unnecessarily a copy there also. ls It is already copied here. And now I go back. I don't need this particular file because I did the CP already. So rm minus rf ultimate word count.java ls. Now I got the basic structure. Remember, com is not needed. No, com is wrong. I need source. So mkdir src cd src move dot com to here. So that now I have got com inside the source and I got source directory Unix. And we have got build.xml also, right? Now, please listen. vi source slash com slash passion slash ultimate word count.java. If you look at the beginning of the program, you can see that I created an enumerated variable. That enumerated variable is the one which is going to count the number of words. This is how you will create a counter. And what I am going to do, whenever I am encountering a new word at the time in my mapper, I am going to tell that increment that counter variable by 1. Look, you have written it inside the map method, but you are incrementing a global shared variable. That's the idea. And this concept is called counters. So you will be using a counter in order to count. For example, the most advanced use of counter is finding out blank lines in the input, data quality. So whenever you are encountering at the time, there is blank lines coming in, what you will do? You will increment that count by 1. You can create another variable, blank line counter, right? So you can add that way and you will add the counter variable. Now, let me show you the input files. How many input files we are having? File 01.txt and file 0. Look at this, file 01.txt. Hello world, then after world there is a comma, then by world, and after that world there is an exclamatory mark. And if suppose you are looking at vi file 02.txt, you can see hello Hadoop, comma, space, goodbye to Hadoop, full stop. Intentionally all these symbols I put. When I run a MapReduce program and you use your old, not ultimate word count, the old, less ultimate word count, what will happen? You will get Hadoop full stop as 1, world exclamation as another 1, world comma as another 1. Why? Because it is a single word. So what I want to do? This type of characters I want to escape or remove, correct? So what is the best possible way to remove that? In your code, you will go, okay, what normally somebody will do? You will go to this particular code and then inside your mapper, you are going to write that, okay, if this particular token, okay, remember the next token and all. I have explained you everything, or the next word, right? In that token, if that is containing a comma or full stop or an exclamatory mark, then replace it with white space or something like that. You will write that code here. That's how normally the people will do. Then suddenly your manager is calling and telling that, hey, some files from the provider is coming, but that is containing a pipe character. What do you need to do now? Production code. Again, you will start the development, and then again you will go to SIT and UAT, and again you will add that hard-coded value. Okay, if that is containing pipe also, correct? And tomorrow another character is coming. It is not sustainable coding, right? What I should do that? All this, I am going to keep it in a separate file. And I am going to call it as patterns.txt. And then I will tell my MapReduce program that while running the code, look at patterns.txt and whatever character is there, remove it. So your manager is telling tomorrow to add one more character, only you will change what? Right? Now where I will keep the patterns.txt?
You send it with along with the command to all the nodes.
How? Only jars can be provided by libjar. That's why I told you this question. Yesterday we learned about libjars. Look at the word minus libjars.
Yeah, we have to
Jar it,
jar it
right?
and
Now,
start.
what about text file? Text file is not a jar. It cannot be jarred. It can be jarred, but it is not a class file. You can't do that. Then where you will put? You will put it in database, or you will put it in a local file system. Remember, your MapReduce cannot read local file system. Then where you will put? Ideally, HDFS. Create a directory and put it. But there is a problem if you put it into the HDFS. Tell me what is the problem? Yes, you can read. There is a problem with the non-functional requirement.
Deadlock will happen.
No?
Two nodes is
But it is reading, right? Not writing.
You can't update.
We are not updating. Updating is happening while the job is not running. The problem is every node is trying to read from HDFS and then trying to compare performance. I told you no non-functional requirement. Performance, security, all these are not functional. So HDFS also I cannot put. Is there any way that I can put it in the memory? And then I will tell all the nodes to refer to that memory. Of course, I will load into that memory only once from the HDFS. It's okay. Right? If you want such memory while you run your MapReduce program, it's called a distributed cache in MapReduce. So what we need to do? Patterns.txt, we will put it in HDFS, but we will tell that create a distributed cache at the time of running so that every node can just refer to it without going to the input and output is the biggest trouble. Performance. And preferably from HDFS, it will connect to name node, boom, blue, all those things, right? Everything can be eliminated. Counters, distributed cache. When you do all these things together, you get a beautiful program. That's why we call this as ultimate word count. Okay, so how you should run everything it is written. I leave it to you. You have to do some exercise now. Look at that. File 01 and file 02, you have to put it into your HDFS. Okay. Then you are going to write ultimate word count, input, output, and then give the minus skip option patterns.txt. What I am doing in my code. If there is a skip option in the code, okay, I am telling that skip patterns equal to true, which means that it will be skipping the patterns. And where that file is going to be there, if you are looking at the code, you will see that, where is it? One minute. Generic option parser, mapper class, remaining, system.exit. Right. This line has to be uncommented. Job.add cache file. That is what is adding into the distributed cache. All right. And how will you run? Minus skip patterns.txt that you have to execute. I want you to do this. I'm not recording because I have given the commands. Okay. compile the code, and after that there are 3 commands there. Look at that. Is it okay or not? It is just running the MapReduce program normally. Now, 1 minute. What was our program earlier? And I have created all the directory structure for you. Refer to this for complete create structure, and just you need to write and I will show you. If suppose you write and, you should not get any error. And it should compile the code. Look, now you know Hadoop jar is created and how to run it. That 3 commands are there in the below part of the code. That please execute it. And this is the most advanced thing that you can do in MapReduce within your scope. Okay. Now, yesterday's program. What is that? CD?
PDF.
Okay, let us take simple MR because PDF MR needs all those things, right? And what was our input file? Let us create another input file today. Hadoop fs minus mkdir November 25 is the directory. Let's create. And this input november.txt, vi input november.txt. Okay, the twinkle twinkle little star is there, right? So Hadoop fs minus put this input file into November 25. Clear? cd dist. I'm not compiling because I didn't change any of my code. Hadoop jar my hadoop.jar. What's the name of the program? com dot bibin.word count. Is it true? Just look. Vi src com src com bibin count is the name of the code. Okay, bibin count. So cd dist. You have to clearly write the name of the code now. Hadoop jar my hadoop.jar com dot bibin dot bibin count and November 25 and November 25 out. What is that? What is this? Application master, the manager for every application. Yarn is coming in. And then the MapReduce is getting executed on the yarn cluster by using yarn. And what are these? That is what you were seeing all these days. By default, how many bytes read, how many records read, how many errors happened, everything is internally by default implemented by Hadoop MapReduce framework as counters. And what I told you just now is how to write your own counter. Okay, and where you see all these things. Go to localhost 8088 plus, I'll make it big. Okay, and then click on the application. This is the application ID that you have seen, application master. And what is it? Tools, server, no. Application, is it tracking? I think it is tracking. History. Yes. And what is this?
Counters.
And click on the counters. Number of bytes read, number of bytes written, number of map tasks, how many records has been read, is there any connection or anything error? And if you run my ultimate word count, you will see one more here. What is that? That counter that we created. Input words. Here, all these counters are given by MapReduce by default. And why you need these things? This is the most important thing for an advanced MapReduce programmer. How many bytes are read for this data? How can I improve it? and he will change that particular, he or she will change that particular code and will come here and will check, oh, okay, my earlier code was reading 10,000 bytes, now it is reading only 5,000 bytes. Wow. Understand? I made a modification to my program. Full statistics of your MapReduce, you will get it here, which is internally implemented as counters. Right? So you can see. Now, another thing. What is your application ID, by the way? Back. This is your application ID. Okay, I'm going to copy it. Copy. And now, I know my application ID, right? Yarn logs minus application I capital ID, and then right click, paste. This is the logs of your application. Remember yesterday I told you that go to that Cloudera and then find out within that every word I have written that system.out. You don't need to. Yarn logs, your application ID, you type in, you get whatever you want. For example, everybody will not be using Cloudera, right? Tomorrow you are going there and you are getting HTTP. This is the yarn logs. What is the command that I type? Yarn logs. If you don't know, make a mistake. Look, it will tell you. Yarn logs, you give minus application ID and give your application ID, and you have options. You can give app owner, you can give container ID if you want to know container level details. How can I know 4,000 node cluster is running? That container failed in somewhere else. Container ID. And node address, IP. You can give. Node name, comma, port. You get the complete status. What?
Where can I track the container ID?
In the logs. Again in the logs, yes. Every statistics will be displayed. Now, did you understand why after MapReduce that output is coming? Counters. There is nothing in MapReduce more you need to know.